Hello, welcome to our first video on arithmetic sequences. So with an arithmetic sequence, we need to be able to identify what an arithmetic sequence looks like. So if we take the first example, we have 6 followed by 20, followed by 34, followed by 48. Write some ellipses and so on. Well, 6 is called A, our first term. And what happens is we have something called a common difference. And that means that we add 14 every time to get the next term in our sequence. Now, a sequence is always separated by commas. In subsequent videos, we're going to be looking at series. For regular A-level, that's an arithmetic series and a geometric series, and that involves a plus sign. Okay, those of you that will be doing A-level further maths, there'll be subsequent videos coming out on something called Maclaurin series in general, which is done in further maths. But for regular A-level, it would just be arithmetic series and geometric series and sequences respectively. So back to our problem. So what we've got here is plus 14 each time. So we're going to write this as A is 6, D, which is our common difference, is 14. Now that we have that, it says to find the nth term of each arithmetic sequence. So we're going to do the following. So we're going to say that the nth term of an arithmetic sequence is always A plus n minus 1 D. So now we're going to sub the values in. So we're going to get 6 plus n minus 1 times 14. And that's just going to give me 6 plus 14n minus 14. And that just simplifies to be 14n, 6 minus 14 is minus 8. So 14n minus 8 is the first term in our sequence. So let's take the next example, B. So we've got 101, 94, 87 and 80. And so on. So our common difference is minus 7 each time. So our first term is 101. Our common difference is minus 7. Let's write the nth term down. So the nth term is A plus n minus 1D. And that's just going to be 101 plus n minus 1 times minus 7. That's 101 minus 7n plus 7, which gives me minus 7n plus 108. Like so. Here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. So here we have a question like this. Again, arithmetic sequence. So we're going to add 2 each time. So A is 5, D is 2, and we're going to write down the formula. A plus n minus 1D. So now we're going to get 5 plus n minus 1 times 2, and that's just simply going to give me 5 plus 2n minus 2, and I'll just simply get 2n plus 3 as my nth term. So here's the second example. So the second example says the following. A sequence is generated by the formula un equals an plus b, where a and b are constants to be found. Given that u3 equals 5 and u8, or otherwise known as u subscript 8, is equal to 20, find the values of the constants a and b. So what we're going to do is to write down this nth term. So un just means the nth term is an plus b. So we have the nth term written down, so we're going to substitute the values in. Well, n is 3, so we're going to say 3 times a. So 3 times a. Now u3 is the value of 5, so we're going to replace that with 5, and we're going to have plus b. Now u8, or u subscript 8, is equal to 20, so we say 20, but the value of n is 8 here, so it's 8a plus b. So we're going to solve a simultaneous equation here. So the b values are the same, that's fine. So we get minus 15 is equal to minus 5a. The minuses cancel. 15 equals to 5a, and therefore we're going to get a is 15 over 5, and therefore a is 3. So now we're going to sub it in to find b. So we're going to say 5 equals 3a plus b. So 5 equals 3 times 3 plus b, and that equals 2. 5 is 9 plus b, and so we're getting minus 9 on both sides. So we get minus 4 is equal to b. Right, so here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. So we have a question here. So we've got un, or the nth term, is pn plus q. Now, the sixth term is 9. So 9 equals 6p plus q. And the ninth term is equal to 11. So it's 11 equals 9p plus q. So now what we're going to do now is to solve the simultaneous equation. So we're going to minus both values, just like we did in the example. So we get minus 2 is now going to be equal to minus 3p. Now they say they're constants, that does not say they're integers, so we can get fractions as our answers. So here we're going to get 2 equals to 3p, and therefore p is now 2/3. Now we're going to sub in to find, so I'm going to sub into the first equation to find q. So I'm going to say 9 equals 6p plus q. So 9 equals 6p plus q. And what we're going to get here is we're going to sub in p. So 6 times 2/3 plus q. And what we're going to get here is 6 times, or what we can do, just times them, so we get 12 over 3 plus q. That should be 9. This should be a 9. And this should be 9 equals to 4 plus q. And then we can minus 4 on both sides. So 5 equals to q. So therefore, we get p being 2/3 and q being 5.